In episode 11, services gave your pods a stable address no matter how many times they were replaced. This episode is about two more things pods shouldn't hardcode: configuration and data. Baking a database URL or a feature flag directly into your container image means rebuilding and redeploying the image every single time that value changes. A config map pulls ordinary, non-sensitive configuration out of your image entirely and stores it as its own Kubernetes object. Key value pairs your pod's reference instead of hard coding. kubectl create config map app config -- from literal log level equals info creates one directly from the command line. You can also define it in YAML alongside everything else, which is the more common approach in real projects. Either way, a pod pulls values from it in one of two ways: as environment variables or as mounted files, where each key in the config map becomes its own file inside the container, holding that key's value as its contents. Secrets work almost identically, for one specific difference: sensitive data, passwords, API keys, tokens. kubectl creates secret generic DB password -- from literal password equals your value. Mount it the same way a config map mounts, as an environment variable or a file. Here's the honest caveat worth knowing. Kubernetes secrets are base 64, encoded, not encrypted, by default. That's obfuscation, not real security. Production clusters layer proper encryption and access controls on top, which is beyond what we're covering today, but don't mistake a secret object for a vault on its own. Now, storage. Episode 5's Docker volumes solve persistence on one machine. Kubernetes needs the same idea, but a pod can be rescheduled onto a completely different worker node at any time, so the storage has to be able to follow it there. A persistent volume represents an actual piece of storage available to the cluster, provisioned by an administrator or, more commonly today, created automatically on demand. A persistent volume claim is what a pod actually asks for. I need 10 gigabytes, read-write. And Kubernetes binds that claim to a matching persistent volume behind the scenes, the same way a Docker named volume abstracted away exactly where data physically lived back in episode 5. A storage class is what makes that binding automatic. It defines how new persistent volumes get created on demand, so you almost never provision storage by hand. You write a claim, and a matching volume appears. Let's watch this in practice. We create a config map with one key, mount it into a pod as a file, then exec into that pod and cat the file. And there's our configuration value, injected with zero rebuilding, sitting exactly where we told it to appear. Let's recap. Config maps hold ordinary configuration outside your image. Secrets hold sensitive values the same way, base 64, encoded rather than truly encrypted by default. And persistent volumes and persistent volume claims give pods durable storage that survives being rescheduled to an entirely different machine. Right now, every service we've built is only reachable inside the cluster, or through clunky node ports. In episode 13, we cover ingress, the standard way real traffic from the internet reaches your applications. Subscribe so you don't miss it. See you then.